The Pew Internet and American Life Project finds that 93% of teenagers 12 through 17 use the internet. So the probability that we're online is 93%, and 55% of those teens have posted a profile on a social media network. So of those kids that post a profile, and notice that this is a conditional probability, because to be able to post one of these profiles, it is given that they're online, and that is 0.055. And so they want the probability that a randomly selected teen uses that uses the internet has posted a profile. Well, if I say, these are my teens, and 93% of them are on, so that means 0.07 are not online. And of these people who are online, I got 0.55 who posted. So that means that there is 0.45 who is not posted. And I want the probability of randomly selecting a teen that uses the internet has posted a profile. So I'm looking at these teens who are online and who have posted. So I'm looking at the top of that tree chart. And that gives me 0.93 times 0.55. That gives me an answer of 0.5115. So there's a 51.15% chance we randomly select a teen who uses the internet and has posted a profile on a social networking site. Tennis great Roger Federer made 63% of his serves in 2011. When Federer made his first serve, he won 78% of the points. When Federer missed his first serve and had to serve again, he only won 57% of the points. Find the probability of all possible outcomes. Well, let's think about this. We have a serve, and 63% of the time he makes first, so that means 0.37 he misses first. Then it says if he makes the first, he won 78%. So that means he wins point. And that would mean, on the other hand, 0.22, he loses point. If he had to reserve again, he only wins 57 of the points. So these are your different scenarios. It's make first and win, make first and lose. This is misses first and wins. And this is misses first and loses. So to calculate these probabilities is actually fairly easy. For this top row, all we do is 0.63 times 0.78. That is 0.4914. This next area, makes first and loses, is 0.63 times 0.22, which is 0.1386. If he misses first and wins, that's 0.37 times 0.57, which is 0.2109. And the last one is misses first and loses, And these would be all the different probabilities. And we would know if we did this correctly, because if you add all those up, they should be 1. Let's take a look at one more. 20% of adult users are in between, internet users are in between 18 and 29. 45% are 30 to 49. The remaining 20%, 8% are 15 over. All right, we already have a lot of numbers here, so I'm going to start off with a tree chart. And I know I got 3 things. This is 18 to 29. This is 30 to 34, or 30 or 49, my bad. The probability of that is 0.45. And down here is 50 plus, and the probability of that is 0.28. A survey finds that 70% of internet users in between 18 and 29 have visited a video sharing site. So that is 0.7 have visited. That means 0.3 have not. Of the 45-year-olds, 51% have visited. So that means 0.49 have not visited. So remember, these have to add up to 100%, or a probability of 1. And then these 50 plus age group, the old timers, is 0.26 have visited something like a YouTube or Vine or whatever else hosting sites there are. So that means 0.74 have not visited. And then you could just go ahead and actually calculate all these probabilities. And all those should add up to 1. And let me get some answers in there. So we drew the tree diagram. Find the probability that a person has visited the sharing site. Notice there's 3 different categories for it. There is young who have visited, there's medium who have visited, and there's older. So we need to add up these 3 probabilities. And if you do that, it is 0.4913. So approximately 49% have visited a video sharing site. Given that a person has visited a video sharing site, find the probability that he or she is aged 18 to 29. So I'm going to go, this is the probability that, let's see, given a person has visited, okay, so we want the probability that they're 18 to 29 given that they have visited. Well, thankfully, we already calculated who has visited, and that was 0.4913. And now the probability that they're 18 to 29 is 0.1890. Therefore, my solution is 0.1890 divided by 0.4913. And if you go ahead and calculate that, that means the answer is 0.3847. So that means young people make up roughly about 39% of the users. I would like you to go ahead and try this mammogram, and just remember that your tree chart starts. It says 1% of people actually have breast cancer. So just to start, and 99% no breast cancer. And they give you the other different parts, and I would like you to go ahead and calculate that and solve that problem.